Hello, welcome back, and it's Mr. C with your Level 6 Math. Today we are doing Saxon Math lesson number 23 on ratio and rate. This is a really helpful lesson in thinking about different things because we use these kinds of word problems or story problems a lot in life, and so this is going to help you think of a way of how to convert those story problems and solve for the answers. So we're going to look at ratios to describe relationships and identify ratios and writing them in fraction form. All right, so a ratio is simply a way to describe a relationship between numbers. If there's 13 boys and 15 girls in a class, then the ratio of the boys to girls is 13 to 15. So we can write this in three different ways, and the order does matter. So boy to girl ratio, that means the boy number will be first and the girl second. So 13 to 15, you can just write it 13 to 15. You can say 13 to 15 using a colon, or you can do it in fraction. And typically in Saxon Math, we're going to do it in the fraction form. 13 to 15. Now the number on top is the first one that they ask for in the ratio. So here it's boy on top, 13 to 15. Either of these ways, any of these ways, we say 13 to 15. All right, in this lesson, we'll focus on the fraction form of ratio. When writing a fraction form, there are three things to keep in mind. We write it in terms of the ratio in order we're asked to give them. So that's why we put the boys first in that last example. We reduce the ratio in the same manner we reduce fractions. And that's why that third method of putting it in a fraction is probably the most useful. It's because then you're going to remember, oh, if I can reduce this, I should reduce this. We leave ratios in fraction form. We do not write the ratios as mixed numbers. So it stays in the fraction form. Even if we could say, 1 3/5 or whatever, we leave that as, what would that be, 8/5 or 8 to 5, okay? So a team lost 3 games and won 7. What was the team's win-loss ratio? Now this is a tricky question because it says win-loss ratio, but the second number is the win one. So that's what we're going to put first, win-loss ratio. So 7 to 3. We can say 7 to 3, 7:3, or 7/3 if we put it in fraction form. So 7/3 is the way we're going to want to write it in this example. Remember, the win is the first one, so we need to put that game first. Number of games won, 7. Number of games lost, 3. So that's our ratio in fraction form. In a class of 28 students, there are 13 boys. What's the ratio of boys to girls in the class? Well, we already know how to solve to find the girls. We take 28 total, subtract 13 boys. That means there's going to be 15 girls. So the ratio of boys, 13, to girls, 15, would just be 13 to 15, 13:15, or 13/15ths, which is the way they're going to write it in the homework. So it's just easiest to practice writing it in fraction form. All right. A rate, so now we're moving on to a new concept here. A rate is a ratio of measures. So below are commonly used rates. Notice that the per means for each. So if we said 55 miles per hour, it means there's 55 miles in each hour. So that's going to be a rate. Common rates are speed, mileage, and unit price. So if we have distance and time, 55 miles in 1 hour, we say 55 miles per hour, or mph. And mileage, if we have distance and we're looking at the fuel used for that distance, we use these all the time in the real world. It's 28 miles per gallon. And then if we're buying something like at the grocery store and we're buying in bulk and it costs $2.89 for a pound, that's going to be like your Honeycrisp apples, $2.89 a pound. You just say $2.89 per pound. All right, so let's look at this. Rate problems are types of equal group problems, which we've been practicing a lot of lately. The rate is in the number of each group. The problems often involve 3 numbers, so distance, time, plus another time. So you have to keep those different numbers separate, and it's easiest if you write it out. So here we see that an example is 165 miles, that's the total miles, if it's 55 miles per hour for 3 hours. Let's look at that in an example problem. So on a bike trip, Jeremy rode 60 miles in 4 hours. Okay, so we know his total was 4 hours. He rode 60. We're looking at how many miles per hour. Well, we can take the distance, 60 miles, divide by the time, 4 hours. 60 divided by 4 is going to be 15 miles per hour. So it's simply reducing that fraction and saying miles per hour. Okay, so then we get 15 mph, or 15 miles per hour. In example 4, we see Mr. Moscal's car averaged 32 miles per gallon on the highway. Predict how far it'll go if he has 10 gallons. So we already know the mph in this one is 32, and we know that he has 10 total gallons, so we can just multiply 32 gallons by 10 total gallons, or 32 miles per gallon. So we're just going to multiply by 10. So we have the distance equals the distance plus the fuel, miles per hour, so we already have that part. 32 times fuel used is 10 gallons. And that gives us 320 miles if we have 10 gallons. Which is pretty good. All right, if this is confusing for you, you can make up a table. So put the fuel used, 1 gallon for 32. So you can just double that for 2, add another 32. So
Good morning. If you have a blocked student, you can come to the lobby. They have arrived. Thank you.
You're welcome. Sorry for that interruption. That's it. That's the rest of the lesson. So just, this is going to be a difficult lesson for many of you. It's going to take some practice. Don't give up. Don't be too frustrated. Just think about it a few times. It's eventually going to click for you. And if it doesn't, you can always refer back to this in the book or watch this video a few times. This is one we'll keep working on. So again, if it's hard, don't get too frustrated. Okay?